Hi everyone, this is Math Done Right, and in this video we're going to be talking about zeros and their multiplicities. So, when we talk about polynomial functions, it's important to talk about their zeros and what their multiplicity is in order to accurately graph them. So the zero, or also known as a root, I'm going to probably interchange these throughout the video just because it's good to get familiar with the vocabulary. So 0 or root of a function is a number a. So I know a is a letter, but in this case it's going to be a number such that f of a equals 0. So all that really means is it's just some number that when I plug it into my function, I get a 0 out of it. Okay? And now the multiplicity of a 0 is how many times that 0 occurs for a given function. So with that being said, those are my two definitions that I need to know. Now let's look at some examples so we can kind of understand what those definitions are really saying. Alright, so for this first example, let's look at f of x equals x minus 2 squared times x plus 5 to the 6th power. Now, I can rewrite this guy as, I'm going to put the equal sign over here because it's going to take me that much room. This is x minus 2 times x minus 2 times x plus 5 times x plus 5 times, I have this 6 times. And it's going to get messy because I don't really want to write it 6 times. Right? So now I can see that the square gives me 2 terms here for x minus 2, and the 6th gives me 6 of these x plus 5s. So this is 6 times. And over here I have 2 times. Now, if I plug in a 2 to this function, I'm going to get, so let's look here. So if I do f of 2, I'm going to get 2 minus 2 times 2 minus 2 times all this stuff down here, but these guys are 0, right? And then if I have 0 times anything, it's going to give me 0. So what that's saying is that 2 is a 0 of my function, right? 2 is a 0. So if I plug in 2 to my function, I get 0. So the way we say that is that 2 is a 0 of this function or root. Now, I can do the same thing with 5, or actually negative 5. So let's look over here. If I did f of negative 5, I would get something, something, and then a bunch of zeros. Right? So this would also give me 0. So that means that negative 5 is a root slash 0. So that's just by eyeballing this equation right here, right? I can see, oh, if I plug in a 2, I'll get 0. If I plug in a negative 5, I'll get 0. For any of these factors, all of these pieces are called factors. This is a factor. And this is a factor. So both of these guys are factors. So is there an easier way to identify the zeros without just kind of eyeballing it? And there is. So let's go to the next slide and talk about that. So I have one factor here of x minus 2 and another factor of x plus 5. And I want to find the zeros of this polynomial f. So an easy way to do that is to set both of these factors equal to 0 and solve for x. So I get x minus 2 equals 0 and x plus 5 equals 0. Now, if I solve this bottom one first, I'll get x is negative 5. And if I solve the top one, I'll get that x is 2. So we already saw that before, but now this is a precise way to do it. I set each factor equal to 0 and I solve for x. So these are my zeros. both of these, x equals -5 and x equals 2. Now, remember when I wrote this long thing out, I had x minus 2, right? All these x plus 5s. And how many times did they occur? Right? The 2 occurred twice. And the x plus 5, all these over here, occurred 6 times. So the multiplicities are determined by whatever these exponents are right here. So we say that the root 2 has multiplicity 2, and then the root minus 5 has multiplicity of, whoops, that was bad, multiplicity 6. So how many times does -5 occur when I expand this guy out? It occurs 6 times. How many times does positive 2 occur? It occurs twice, and that's determined by these exponents up here. Now, just a quick aside, let's say it's something like f of x equals x minus 2 times x plus 5 squared. Well, we know the -5 have a multiplicity of 2. That's easy to see. But then this 2 right here, there's no power up here. But it's always assumed to be a 1. So this would have a root 2. Root 2 with multiplicity. I'm going to use an abbreviation with multiplicity 1. And then -5 with multiplicity of, that was all bad. Let's start over on the word multiplicity. Multiplicity of 2. Right, the -5 occurs twice, and the 2 occurs once inside of my function. Alright, let's do another example. Alright, so this one's going to be a little bit tricky, but that's alright. So let's look at the function f of x equals x squared minus 2x plus 1. Now, this is much different than what we just looked at, right? This is not in what we call factored form. I can't see all the factors immediately. So the first step I need to do is to put this function into factored form. And that's going to look like x minus 1 times x minus 1, or equivalently x minus 1 squared. Now I want to find the zeros, 0 or zeros, put that in parentheses. So I set the factors equal to 0, but there's only one factor, it's just x minus 1. So I set x minus 1 equal to 0, and I solve, and that gives me x equals 1 is my 0. Now for the multiplicity, I look at how many times that root occurs. So in this form, I can see that it occurs twice, but then looking at the exponent, I can see that it occurs twice also. So there's two ways you can look at it. If it's in a form like this, you count it up. If it's in a form to where it gives you the exponent, it's just the exponent. So multiplicity 2. And now you want to say that a multiplicity is associated with a root. So 1 is a root with multiplicity 2, because that's how many times the root occurs in this function. All right, well, that's all I've got for the zeros of a function and their multiplicities. Make sure you check out my other videos. I'm going to be going into more detail about what the multiplicities and the zeros of a function do for you, and how we can use that to graph them with even more detail. All right, well, thanks for watching. Bye.